Hi, in this video, we will solve the third question of IIT JAM 2021 mathematics paper. This is a real analysis problem, which is an MCQ. It has 4 options, out of which only one is a correct option. We will see a method of quickly finding the correct option for this problem. The method discussed here can also be used in solving many other problems of IIT JAM, which will help you identify the correct option fairly quickly. Of course, finding the correct option is very important for clearing IIT JAM. But if you want to really thrive after getting into IIT, I strongly suggest you understand the mathematics behind the correct answer. And this is something we are going to discuss at the end. So let's get started with the problem. Here's the quickest way to find the correct option. The trick is to eliminate the wrong options. Alright, that is what we are going to do now. Now in this problem, notice that the given function is a continuous function and it's also periodic with period 1, which means that the graph of the function is repeated over all the intervals of length 1. Now the first option says that f is not necessarily bounded on R. So what we are going to do is we are going to check the behavior of f on the interval 0, 1, and that will be sufficient for us to guarantee whether it is bounded or unbounded. Now, f is a continuous function on the closed and bounded interval 0, 1. It is a property of continuous function that if it is continuous on closed and bounded interval, then it is bounded as well. That implies the function is actually indeed bounded on 0, 1, which also, using the periodicity of the function, implies that it is bounded on entire R. So that eliminates the first option. Cool. Now for option B and C, we will present a counter example that will eliminate both of them. The counter example is a trivial one. Consider this constant function f of x equal to 0 for all x. Now why does it eliminate B? B says that there exists a unique x0 for which this identity f of x0 plus pi is equal to f of x0. Here for the constant function, this identity is satisfied for more than one x0. Therefore B is eliminated. Now for C, it says that there is no x0 for which this identity holds, but the given function is a constant function for which it does hold for in fact all the x0. Therefore C is also eliminated. So what we are left with is option D, and hence D must be the correct option. But it is a bit tricky question to prove that the D option is correct. And if you're wondering why D is correct and how one can prove it, just hang on. We are going to discuss that as well. Cool. So let's prove why D option is correct. Now, first observe that if you can find one x0 for which this identity holds, then using the periodicity of the function and induction, what we have is that f of x0 plus n plus pi is equal to f of x0 plus n for all natural number n. Now if we take x0 plus n to be xn, then what we get here is that f of xn plus pi is equal to f of xn. So getting one x0 gives you infinitely many xn's. So therefore it suffices to find one x0 for which we have f of x0 plus pi equal to f of x0, and that is what we are going to do. Now for that, let us define this function g of x to be equal to f of x minus f of x plus pi. So the whole problem is equivalent to showing that g takes value 0 for some x0. Now the problem becomes fairly easy to solve afterwards. One thing to notice is that the function f attains its bound on 0, 1 because it is a continuous function on closed and bounded interval, and let x1 be a maxima for that function f. So this means that f of x1 is greater than or equal to f of x for all x in 0, 1, And then again, using periodicity of f, you can actually deduce that f of x1 is actually greater than or equal to f of x for all x. Therefore, here's what we get. We have g of x1 equals f of x1 minus f of x1 plus pi, which is greater than or equal to 0. And also, if you consider g at x1 minus pi, this is equal to this quantity, which is less than or equal to 0. So we have shown that g takes negative, non-negative and non-positive values. Now this is a good news because we can now apply intermediate value theorem, which tells that the function g, which is a continuous function, uh, for this function there exists an x0 between x1 minus pi and x1 such that g takes 0 value, and this is the x0 we were looking for, and this completes the proof.